In this exercise of rational numbers, chapter 1, class 8th mathematics, we have learned the way to find rational numbers between any given two rational numbers. For an instance, we have rational numbers as 2 over 3 and 5 over 3. So whenever we try to find rational numbers between two given rational numbers, we look at its denominator. Here denominators are same, so there will be no problem in finding the rational numbers between them. So it would be 3 over 3, 4 over 3, separated with commas because they are different. So these two were the rational numbers between these two rational numbers if we consider denominator as 3. Although there could be many, infinite number of rational numbers, but their denominators would change. So this is first way. Now what happens if we do not have the denominator as common? For an instance, we have 2 over 3 and we have 3 over 2. Now how we will find rational numbers between them? Well, we have learned two approaches. First approach is simple. Just make the denominator same, and we could do it by taking the LCM. Here it would be 6, so 3 2s are 6 and 2 2s are 4. This corresponds to this number. And how we can write it in terms of denominator 6? While multiplying it with 3 numerator and denominator, it would give us 2 into 3, 6, 3 into 3, 9, because we do not have to change its value ultimately. So now we can easily write that is 5 over 6. That is rational number between these two rational numbers. 6 over 6, 7 over 6, and 8 over 6. And then we will be asked to find 1, 2, 3, 4 rational numbers between them. Then this approach is okay. But if you are required to find 10 rational numbers, then you will have to increase your denominator. That is, you could make it 12 by multiplying this whole with 2, numerator and denominator. Similarly here in numerator and denominator with 2. So it will get increased, that is, denominator will get increased according to the number of rational numbers asked in between them. And the another approach, but in this case your denominator would not be same, is simple one. That is the mean method, which you have studied in your 7th standard. That is average of two numbers. So these are two numbers, we will take its average, 2 over 3 plus 3 over 2. Whatever will be the answer, you will divide it with 2. That number will lie exactly in between because you are dividing the addition of these two numbers. This will be very similar to this. Here you have a number line. This is 1.2 over 3 and 3 over 2 is your another point. This one and this one. So what would be its half? It would be addition of it and then half, as we have here. To make it more clear, you have 1, suppose here, and 3 over here. What is in between? Obviously, it's easy, it will be 2. And how you can go in finding 2? Well, you will sum it. 3 plus 1 is 4 and divided with 2, that is half. You get 2, that is this number. The same we are doing here. So how it will be done? LCM will come 6, 3 2s are 6, 2 2s are 4, plus 2 3s are 6, 3 3s are 9. Obviously this bigger denominator comes 2 as it is. This is whole numerator part. 13 over 6. This whole is getting divided with 2 over 1. So this one goes upwards. That is 13 into 1 divided with 6 into 2. That gives you 13 over 12. So this middle point is 13 over 12. So using mean method, we have found another rational number between 2 over 3 and 3 over 2. And now if we have to find other rational number, we will just take these two and we will average it. That is mean again. And after finding that, we will be able to find a rational number between these two rational numbers. Similarly, we can find between these two rational numbers by taking their mean. So in this way, we find rational numbers between any given rational numbers by using two methods. So with this concept, let's try to solve our exercise. Question 1. Represent these numbers on the number line. Number first is 7 by 4 and second is minus 5 over 6. Prior solving this question, let us define unit. So an individual thing or person regarded as single and complete. For an instance, we have seen a brick wall which is made up of individual units of bricks that are complete in itself. Therefore, it says unit is something which is complete in itself, but which can also form an individual. For an instance, here it can form a complete brick when organized in certain shape to make a larger or complex whole. Therefore, a unit is the smallest individual thing which can form complete another body. So with this, let's solve our question. So we have to represent these two numbers, that is 7/4 and -5/6, on a number line. So whenever you tackle such a question, first of all look at the denominator part. The denominator tells the number of equal parts into which the first unit has been divided. That is, it tells the number of divisions a particular range has been divided into. And also we have a numerator, that is the numeral above the bar, that is the numerator tells how many of these parts are considered. As you know very well from your previous standards that rational numbers come from the word ratio. Therefore 7/4 represents there are 4 equal parts out of which we are considering 7. Again here there will be total 6 parts, that is we will divide each unit into 6 parts and we will take 5. Negative just means that we will move towards left hand side of a number line, that is towards left of 0. So with this understanding, let's solve our first part. So 7/4, here we know we have to divide a given range into 4 equal parts and out of which we have to take 7. So how we will know the range? So here is a trick for that. Just write the denominator and in the numerator part write 0. Another extreme of the range will be just write the denominator as whatever it is given. Here it is 4 and write the same number above it, that is 4 in this case. So what is 0/4? It is equal to 0. And here this gets cancelled out, that equals 1. So you got the range. The range will be from 0 to 1 on a number line. So we have done the same, wrote 0 here and 1 here, and from the denominator we will get the number of divisions, that is we have to divide exactly into 4 units. So here we have a unit, that is this is a unit, this is a unit, a unit and unit. When we take 4 such units, this one, this one, this one and this one, that completes our extreme points of our range, that is from 0 to 1. But here is the take, you have to consider 7 such units because they are positive, so we will move towards right hand side from our extreme range, that is in this case we have 0, so we will take 1/4. Here it is 1/4, here it is 2/4, 3/4, 4/4, which also means 1 because when you cancel it, it gives you 1. But we are not done yet. We don't have to take 4, we have to take 7, that is we have to represent 7 parts out of total 4. So we will move towards right because it is positive. So this is our 5th part, 6th part and 7th part. And also we are asked to represent the following number, 7/4. Therefore this is our 7/4 because we have 7 divisions here and we will encircle it with a circle. So that is our first. With this, second will be easy to solve now. We know we have to divide the range in 6 equal parts, and negative means just the direction on the number line. We'll have to move towards left side of a number line. Now we are finding the range. So as I told you earlier, the trick is simple. Write the denominator part. Here it is 6 in the question. Here we have, and above it write 0 first of all. So it gives you 0. So one of the starting point of our range is 0. So here we have 0. And another one, obviously it is negative because we are asked to represent negative number. So it will be towards left side of a number line. So again the trick, just write the denominator 6 and write 6 above it. Obviously we have negative sign. Sign is just for representation purpose. You write, you cancel it, you get again 1. So here are 2 points, -1 and 0. And we have to divide this range into 6 equal parts. So here we go. 1, 2, 3, 4, 5 and 6. By the way, these represent that this number line is endless because rational numbers have no end on either side of the number line. And also between any two integers, rational numbers or whole numbers, there are infinite numbers of rational numbers. So we were asked to represent -5/6. So now it is easy. Since we have represented it, always write corresponding rational number below each division that you have made. Here it was -1/6, -2/6, 3, and so on. So 5 lies here. You mark the point and encircle it with a circle. So this is how you represent a rational number on a number line. That was your first. Question second, represent -2/11, -5/11, and -9/11 on the number line. Let's revisit the integer number line. So integers are on both sides of number line. Center is 0. This arrow means that these integers are endless, and within integers we have rational numbers. Also 0 is neither positive nor negative because 0 has no negative value of it. Also 0 is a rational number because it can be written in the form of p by q, because 0/1 follows the condition of rational number but not its reciprocal. We have studied in previous exercise. So positive integers towards right side of 0 and negative towards left side of 0. With this, let's solve it. We have to represent these three rational numbers on a number line. So what we infer from these rational numbers? That we have to divide the range in 11 equal parts, and negative means we will be representing towards negative side of a number line. So let's first find the range. Obviously the trick, write the denominator 11. First we have 0, and then other endpoint would be 11/11. Negative is just for our direction purpose. Solve it. It gives you 1, it gives you 0. So ranges from 0 to 1, obviously 0 will come here. So you draw a number line. The extreme points are 0 and -1 because we have negative sign, and we have to divide it into 11 equal parts. This you can divide by estimation, but you have to write these points below each marking. That is -1/11, -2/11, and so on till -11/11. And here 11/11 simply means 1. Also here it was 0/11, which eventually means 0. Now we are required to represent these numbers. Well, now it is easy. -2/11 is here. Mark it and encircle it. First one is done. Second is -5/11. It is here. Mark it, encircle it. -9/11. Here, mark it and encircle it. And this was the trick to find the extreme points. Well, it will always turn out to be 0 and 1 by using this trick. But this varies from question to question, which we will study in later exercises. With this, second is completed. Question third. Write 5 rational numbers which are smaller than 2. Again, we have a number line. Here is our 2, and we have to write 5 rational numbers which are smaller than 2. So one of the answers could be 1, 0, -1, -2. We have 4, and 1 is -3. So total 1, 2, 3, 4, 5 we have. This can be one of your answer, but in standard 8th or in class 8th, if you will write so, that will be too childish. So we will dig deeper. We can divide any 2 points in 2 units. That is, if we take division here, here, and here, that is half of any 2 points. So we will be left with these points. Number 1 is 1, and when we travel half, it will be 0.5 or 1/2, because we have divided it into 2 equal parts and we are taking 1. So this will be 1/2. So we have written 1/2. Then we reach 0. So we wrote 0. Then one of the other point could be -1. So we wrote -1. And obviously this point was left. So it is -1/2. So we wrote -1/2. This we are simply dividing any 2 integers into 2 equal parts. And obviously the numbers earlier, that is 1, 0, -1, -2, -3, are also rational numbers which are smaller than 2. So there could be any number of answers. Whichever you find good, you can write it. That was your third. Question 4. Find 10 rational numbers between -2/5 and 1 over 2. So first of all, we see the number. We have different denominators. First of all, we will make denominator same, and you know very well how to do so. We'll take the LCM. LCM will come 5 into 2 is 10. So 5 2s are 10, 2 2s are 4. Obviously of negative sign, so minus 4. Here again, denominator is 10. So 2 5s are 10. 5 into 1 is 5. So we got the two extreme points. We will write it minus 0.4 and 5 over 10, and 0 would lie somewhere in the between. So we will write these points: 4 over 10, 3 over 10, 2 over 10, 1 over 10, 0. Minus 1 over 10 towards negative side of the number line, minus 2 over 10, minus 3 over 10, and it would be minus 4 over 10, or simply negative of 0.4. The question was asking for 10 rational numbers. So do we achieve 10 rational numbers? We will not count these, this one and this one, because we were asked to find between them. So these are excluded. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. So we cannot use denominator as 10. Let's make denominator as 20 by multiplying these numbers with 2 by 2. Again, 2 by 2. We do not change the value, because if we cancel it, we get the number back. So it would be minus 8 over 20, and here we have 10 over 20. Now denominator are 20, and we will have plenty of rational numbers between them. So we are excluding this, because this is very similar to this. We will not count it, as we have not done here. These are extreme points. That is, if you solve it, you get this. That is, 2 4s are 8, 2 1s are 2, 0, 2 2s are 4, 5 2s are 10, therefore minus 2 or 5. We will not count it, because these are extreme points. Again here, when you solve it, you get 1 over 2, as here, 0 0 cancel out. So we have to divide. So this would be minus 7 over 20, minus 6 over 20, minus 5 over 20, and so on and so forth. This would be 2 over 20. And when we write these numbers, these are total 10 in number. So there can be many such rational numbers. For an instance, this would be 3 over 20, 4 over 20. And what would be this? 9 over 20. So with this, you got an idea how to solve such type of a question. Just make the denominator same and find the corresponding rational numbers between them. That was your fourth. Fifth, find 5 rational numbers between 2 over 3 and 4 over 5, minus 3 over 2 and 5 over 3. And the third part, 1 over 4 and 1 by 2. Again, in the first look, we watch them. Different denominators. Make the denominator same. Let's make denominator 60. We have 2 over 3. How we can make denominator as 60? If we multiply denominator with 20, it will give you 60. Doing so, we're changing the value of this number. So we have to do in numerator as well, because if you cancel it, just get back 2 over 3. So that gives us 40 over 60. What about this? 4 over 5. How can I change it to 60 as denominator? Well, we know 12, 5 is 60. Our value should not change. Therefore, we have to multiply in numerator as well. That's why you multiply on both numerator and denominator. This gives us 4 to the 8, 4 ones are 4. Obviously, 12 into 4 is 48 over 60. So here we have extreme points as 40 over 60 and 48 over 60. We will not consider it. We have to write between them. So obviously, our range is 40 over 60, and somewhere here it would be 48 over 60. These are our ranges. That is two extreme rational numbers between which we have to find the rational numbers. So another would be taken as 41 over 60. It would lie here somewhere. Then we have 42 over 60, 43 over 60, 44 over 60, and 45 over 60. Then we could have 46 over 60, but since we have achieved 5 rational numbers, our answer is done. Obviously, there can be many more such rational numbers in each of these questions, because between them, we can also have rational numbers, which we can easily find by taking its mean or the average. So that is our first. Second, let's make the denominator same. Let's make it 6. So we have negative 3 over 2. How we can make it 6? 2 3 is 6. So we have to multiply numerator as well so that value doesn't change. Minus 9 over 6, 5 over 3 into, we have to make 6. 2s are 6, 5 2s are 10. We get 10 over 6. So two extremes are achieved. Minus 9. Why we are writing minus 9 on this side? Why not this side? Because negative is represented on left side of a number line. And another extreme point is 10 over 6. And you can have many rational numbers between them. One could be minus 8 over 6. Another could be minus 7 over 6. Obviously 0 will come somewhere here. So we have 0. Then we have positive rational number 1 over 6. 2 over 6. We could have 3 over 6 here. But we don't have to write it because we have found 5 such rational numbers. That was the second. Now the third part. So you might be confused by this time how we get an idea that we have to make 20 as denominator. Well, this comes with practice. First of all, we would try to make it 15. There we would not get sufficient number of rational numbers as we had the same problem in our previous question. So we shifted towards greater denominator. So we will show here what is the problem. So first of all, we can make denominator same by taking LCM. 4 to the 8. So if I make it 8, I have to multiply it with 2 on both numerator and denominator. It will be 2 over 8. Obviously here 1 over 2 into with 4, I'll be able to make it 8. Between them, although we can have many rational numbers, but with the same denominator as 8, we can only have one rational number. That is 3 over 8, which will not serve our purpose of solving 5 rational numbers. So we shift towards greater denominator. So we tried for 16. There we also did not get 5 rational numbers. Then we moved further by multiplying 16 into 2, 32. And there we were able to achieve 5 rational numbers, which we are going to show you now. So with practice, we found that we have to shift further to make denominator as 32 common. So 1 over 4, multiplying it with 8 in numerator and denominator would give you 8 over 32. 1 over 2 into 16 to the 32. So 16 and 16. That gives you 16 over 32. And you know very well 8 over 32 and 16 over 32. 8 over 13 will be smaller than 16 over 32. Why? Because here we are taking 8 parts only. Here we are taking 16 parts out of 32. Now, one of the answer could be 9 over 32, 10 over 32, 11 over 32, 12 over 32, and 13 over 32. Obviously, 14 over 32 also, 15 over 32. It solves our purpose. We are able to find 5 rational numbers. So this is a choice that has to be made by practicing. So with this, the doubt is clear that why we are only making here it as 60 and here 32, and here we were able to solve with only 6, because if we don't get the desired number of rational numbers by making denominator common, we have to make denominator bigger. That is, whatever we achieve in first LCM, we just multiply it with some common multiple. For example, here we multiplied 15 with 4 to make our LCM as 60. Here we multiplied our LCM 4 with 8. 4 is 32. Our aim should be fulfilled no matter how bigger our LCM goes. So that was your 5th question. Question 6. Write 5 rational numbers greater than -2. This time we have -2. -2 lies here on a number line. Greater means we have to find rational numbers towards right side. So obviously easy number could be -1, 0, 1, 2, 3, 4. But as we told you earlier, it would be too childish to write them. So we will dig deeper. Again, 1 is -2. Well, this is the range. If we divide again these two numbers in half parts, so it would lie somewhere here, again here, and here. So what is this thing? It is -3 over 2. because minus 3 over 2 is nothing but negative of 1 and 1 by 2. That is, we have 1 complete and half more, because it is a mixed fraction. When you solve it, 2 into 1 is 2 plus 1 is 3, 3 by 2. The same thing here. So this is negative of 3 over 2. Again, the next point is this one, minus 1. Now this would be half, obviously, because it lies between 1 and 0. Or in this case, negative 1 over 0. It's half. So minus 1 over 2. Minus just represents the direction. So this is the point. The another one is 0 and 1 over 2. So we got 5 rational numbers. So what would be other? Other would be 1. So we can write 1. Because we have stated there can be many more such rational numbers. What would be another? It would be here, because we are dividing in half. This is half, consider it half. It would be 1 over 2. And what would be next one? It would be 2. The next one would be here, 2 and half. That is 2 complete. We have 2 complete, and further we have half. This is also a mixed fraction, which simply means 2 to the 4 plus 1, 5 over 2. Improper fraction. This is proper fraction or mixed fraction. By the way, improper means where numerator is bigger than denominator, and the proper is where numerator is smaller than the denominator. For this, 6th question is solved. Question 7th. Find 10 rational numbers between 3 over 5 and 3 over 4. Again, the same concept, just the different question. Well, you can get a hint from the question itself. It is asking for 10 rational numbers. 10 is a big number. That is, it is asking for quite a high number of rational numbers. So we just get a hint that least LCM will not suffice our purpose, but just for demonstration, let's do it. Make our LCM as 20. Now we will not tell you how it becomes 20. We'll just straight away write. In first part, we are making LCM as 20. How we do so? By making the denominator is 20. So 5 4s are 20. Similarly, we have to multiply it with 4 here. 4 3s are 12 over 5 4s are 20, and this one 4 5s are 20. Again 3 5s are 15. Clearly, we have in between 13, 14, 15 only 2 rational numbers. 2 rational numbers. So we will not take 20 as LCM. Second, LCM as 40. Well, in this case, it will not be LCM. It will just be a multiple, because LCM is the least common multiple. So it would be wrong to write LCM as 40. So we will not write it as LCM of 40. We will just write it as making denominator 40. So we just multiply it with 2. So 12 2s are 24, 22 is 40, and 15 2s are 30, and 22 is 40. Again, how much rational numbers we get? Only, count it, 25, 26, 27, 28, 29. Only 5 rational numbers. We will not consider this case as well. Third, let's make it 80. Making denominator den, short form of denominator, as 80. So again, we will multiply it with 2 or multiply it with 4. Same thing. So 48 over 80 and 60 over 80. So we get total as calculated 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, obviously 60 over 80 is our extreme point. We will not calculate it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, this solves our purpose. So your answer could be, these all will have denominator as 80. So this is your required answer, because we were able to find 10 rational numbers between 3 by 5 and 3 by 4 when we made denominator as 80. While in your answers, denominator has been made to 160, which is also not wrong, which you could easily do by multiplying this with 2. With this, you got an idea that answers written in the back of the textbook can have many possible values. So do not stick with it. Always use your mind using the concept. You will reach the answer in many forms. So that completes your exercise, and that was the last part of this exercise.